now we're ready to look at our first counting rule, which we'll call either the basic counting rule or the multiplication rule. You see them all over the place with the same thing. The idea is we're just looking at the number of possibilities in the first step of a process, and then we multiply it by the number of possibilities for the second step. And when I say steps in a process, what I'm saying is, right, if I'm rolling 2 dice, I don't want to think about it like rolling 2 dice. I want to think about it as like a process, a series of steps where I'm rolling a die and then I'm rolling another die. It's like, in terms of outcomes, those are exactly the same thing, right? Whether I roll 2 dice at the same time or whether I roll one and then roll the other, it's exactly the same. And so if I can think about it as steps in a process, this makes this multiplication rule work and become much easier to work with. So again, we're just multiplying the total number of possible outcomes, but let's go through a couple of examples to illustrate what's really going on here. All right, so suppose we're in some English class where we're required to read one novel from a list of 11 and read one volume of poetry from a choice of 8 different possibilities. All right, so if we're required to do that, how many actual total possibilities are there, right? So we've got 11 possibilities for novels, 8 possibilities for volumes of poetry. How many is that total? Well, this is definitely one of those things. I do not want to make a tree diagram with like 11 branches and then 8 branches off of each one of those. I can just use my multiplication rule, right? So I have 2 choices, and so I make 2 little like blanks for myself because I can think about this as 2 steps, right? I'm not thinking of it as a novel and a book of poetry together. I'm thinking about it as separate choices, right? And there were 11 choices for the novel. There were 8 choices for these volumes of poetry. And now I just need to multiply those out. And when I do that, I get 88 total possibilities. Okay, that is much easier than writing out a whole tree diagram and sample space and everything, especially if that's all I really needed to know. All right, so that's that. Let's look at another one. In this example, we're looking at choices for an appetizer, a main course, and a dessert, and we're allowed to choose one of each. How many different meal options do we have? Okay, so this idea that I've got soup, salad, or breadsticks for the appetizer, I've got hamburger sandwich, quiche, fajita, or pasta for the main course, and pie or ice cream for dessert, those are completely irrelevant, okay? All I care about is how many things there are. Right, so soup, salad, or breadsticks is 3 choices. Hamburger sandwich, quiche, fajita, or pasta, that's 5 choices. And this dessert, pie or ice cream, that's 2 choices. I don't care what those choices are, at least at this stage of working through these counting rules. I only care about how many things there are. Okay, so now I've got 3 different steps, right? Again, I don't want to think this is a meal as a whole. I want to think about it as an appetizer, main course, and then a dessert. Okay, so I had 3 choices of appetizers. I had 5 choices for my main course, and then I had 2 choices for my dessert. Same idea. I can just multiply through here. So 3 times 5 times 2 gets me 30. All right, there are 30 possible meals combinations that we could have here. Okay, let's just do one more. So obviously, all people that teach probability end up in the same place in the end. I'm sent to the bad place after dying, and my punishment is to flip a coin 100 times and then record whether each flip was heads or tails. And I have to do this until I get the same outcome twice. In other words, so I'm going to have this big long thing of heads and then tails, right? It'll be like heads, tails, heads, 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 tails, tails, right? With 100 things written here. And the first time that I get the same 100 outcomes in a row, I get to actually stop this. Okay, so let's figure out how many total possibilities there are for this, right? That'll help me figure out how many times I would actually expect to have to do this experiment of flipping a coin 100 times before I actually repeat it. Okay. So, for the first flip, right, I don't want to think about this as 100 flips. I want to think about this as flipping a coin and then flipping another and then flipping another, or just flipping the same coin 100 different times. It doesn't matter, right? But I'm thinking about it as individual steps here, okay? So, right, I'm going to need to make 100 different blanks. So I'm just going to do a dot, 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 you know? Because really, like, what are the total number of possibilities for the first flip? 2. I could get heads or tails. What about the second one? 2, 2, 2, right? They're all going to be 2, right? Because I'm doing the same experiment every single time. Right? This is going to lead us into something useful, right? If I'm doing the same experiment every single time, then this is going to be 2 every single time. And how many of these do I have? I have 100 of them, right? Because I need to flip that coin 100 times. So if I multiply 2 times 2 times 2 times 2 times 2 100 times, I hope all of you have been through enough math or seen enough math that you're getting that we don't actually have to put that in our calculator 100 different times. Right? What is this really? That's what 2 to the 100th power is. Right? That's what 2 to the 100th power means, is 2 times 2 times 2 times 2 100 times. Okay? So if I do 2 to the 100th power, hopefully my calculator doesn't explode. Pretty darn close, though. So this is, if you put this in your calculator, you should get something that looks like 1.26765, right? And so on. And then you'll get something that looks like E30. So whether you're using a TI or a Casio or something like that, it doesn't really matter. You're going to get something that looks very similar to this. Sometimes it's a lowercase e. Sometimes it just shows something like scientific notation. But that's really what this is. Okay, so I just wanted to deal with that right here so that if you see this in your calculator, you'll know how to handle a situation like this. What this is scientific notation. Okay? So what this is 1.27. I'm just going to round here to 3 decimal places. 1.2067. Or, wait, 1.268 if I round to 3 decimal places here. And then it's times 10 to the 30th. So that E means times 10 and then raise that to whatever comes after the E. So the E30 means times 10 to the 30th. And this is how they write things out in scientific notation. What it really means is, since this is a positive 30, I need to move the decimal place 30 places to the right and then fill in the zeros. So 1, 2, 3, right? And then 27 more times. So 1, 2, 6, 8. And then 0, 0, 0. Okay, so that's 6 places I moved it over. 9, 12, 15, 18. I literally can't even fit that on my board. Right? That's that huge of a number. So in other words, I'm going to be in the bad place for a very long time. That's it.